Hey everybody, this is Mr. McKee again with NET 226. Today I'm going to be going over Packet Tracer 6.4.5, which is configure static NAT. Alright, we have a pretty straightforward topology. You got a router, you got a local area network over here, then you have an internet connection, then you have a computer connected directly to the internet, and a laptop connected directly to the internet. Notice this is on separate networks. Alright, you have a routable network out here on the internet, then you have a router, then you have an inside network, and server 1 has an inside inside IP address. Notice that, and then it should, I haven't even looked at the lab yet, but this should translate for the outside using NAT for that IP address. Alright, so people come in, they go to this IP address, but it would actually go to this server on this IP address. Let me click on it, check it out. Yeah, see that? 172.16.16.1. This is pretty standard on if you have like a web server or another kind of server that's hosted for online users, which mostly these days everything is. That server will actually have a different IP address than the actual outside IP address that people see, partly because security concerns, but only that router and obviously the people inside know that what the inside IP address is. Everybody outside doesn't know because it's showing up as 64.100.50.1. And thinking about, well, that's not quite in our same range as IP addresses, but 209 is close, and actually 64 is really close. All right, so let's get started on this thing. All right, in IP version 4 configured networks, clients and servers use private addressing. Before packets with private addressing can cross the internet, they need to be translated into public addressing. Servers that are accessed from outside the organization are usually assigned both a public and private static IP address. In this activity, you will configure static NAT so that outside devices can access an inside server at its public address. All right, so the first thing I want to do is test access without NAT. Attempt to connect to server 1 using simulation mode. Switch to simulation mode down here on the bottom right. All right, and you'll see the simulation panel will open up. From PC1 to L1. All right, PC1, L1 is the laptop. Use the web browser to attempt to connect to server 1. Web page at 172.16.16.1. So I'll do it on the PC. Two 2.16.16.1. Right click and go. Alright, continue to click capture forward button. Notice how the packets never leave the internet cloud. The attempt should fail. Alright, so let's back this thing up and see what happened. Alright, so the request timed out. And actually, the request should start from here and go out. And that's weird why it didn't. Let's do it again. Alright. Oh, I love the simulation mode. I'm going to restart everything. Alright, so restart everything. I'm going to go ahead and do fast forward time. Go to simulation. Go to PC1. Here, let me watch it. Alright, 172.16.16.1. It should be sending out a packet that way first. But it doesn't. It comes back from the internet. Alright, so it'll time out. Oops. right, so the attempts fail. It might be easier to just ping it. Let's see what I can do. Go here, let me get ping 172.16.16.1. Because it should give you one out first and then come back when I can't reach it. All right, there we go. Now this is starting there. Now it goes out, then it comes back. I don't know why it didn't show you the first time, but that's the way it should look. Obviously, you have to originate a request from there to go out there. All right, so that's what you should see. All right, let's see. Exit simulation mode to real-time mode. From PC1, ping the R1S000 interface, which is that one right there. All right, so we're getting response back. So we're reaching there. All right, so view R1 routing table and running config. View the running configuration of R1. Note that there are no commands referring to NAT. An easy way to confirm this is to issue the following command. All right, click on that. Hit enter. Go to privileged exec mode. All right, show run. Put a pipe in there. Include NAT. Okay, easy way to confirm this is the show. Okay, so there's no NAT right now. And if we did a show run without that, all right, there's our running config. All right, verify the routing table does not contain entries. Contain entries referring to the IP network addresses for PC1 and PC2. So show IP route. Let's see. No 10 dot anything on there. Just 172s, which are on the inside. See other gigabit interfaces. All right. This is at the L is actually the interface itself, which is that inside interface right there, gigabit 00. This is the network it's on, /28. All right. And let's see. That's the outside interface right there, 0000, and it's on this network. And show IP NAT executions. All right, so nothing. All right. So part 2, configure static NAT. Configure static NAT statements. Refer to the topology. Create a static NAT translations to map the server 1 inside interface to its outside interface. Okay. So we're going to do IP NAT inside. Let's go to privilege global config mode. Config T and IP NAT inside source static 172.16.16.1 and then the outside 64.100.50.1. All right. So configure the interfaces. So it tells us how to do the inside interface. So interface, gigabit 00, IP NAT inside. All right, and then configure S000 public interface as an outside interface. So interface serial 000, whoop, 000, IP NAT. And see if I do question mark, it either gives me inside or outside. So outside. All right, so that's there. All right, verify connectivity to the server 1 web page. Open the command prompt on PC1 or L1. I'm going to do PC1. If I can click the right thing. All right, there we go. All right. Ping the public address. (64.100.15.1). It might do an ARP translation the first time. Yep, there we go. All right, so we got good contact from there. Verify that both PC1 and L1 can now access server 1 web page. Let me go to L1, and instead of pinging it, I'm just going to put the IP address in there. All right, 64.100.15.1. All right, there's a server. And just remember, you cannot go to the inside interface. 172.16.16.1. All right. You can go inside the network, which is this one's inside the network. All right, so that's inside the network. So everybody's sitting inside this, inside R1, between R1 and server 1. They can all ping the server with an inside address. And I don't know if they'll let you do the outside address. Probably should. All right, let me try 64.100. All right, so that's not working. But don't worry about that right now. But I kind of figured that wouldn't work. All right, but that's a routable IP address and trying to ping it from the inside. Can't work. I can't do it. So there you go. And matter of fact, that's an issue a lot of times with people internally being able to get into your network when you're hosting like an internal web server. If they're on an outside network, it's easy, just like being on PC1 or L1, getting over here. But there's a I forget what the terminology is for it, but our firewall had the same issue. We had to, it's kind of like you make it do a U-turn in the router and come back into the inside network. Because in real life, you want to be able to go to the DNS, name, URL, the IP address, and inside you want to be able to go to the local address also. All right, so let's see. Use the following commands to verify the static NAT configuration on R1. So if we do exit and then do a show running, oops, exit, show run. Right here, IP NAT inside source static. Okay, if I do a show IP NAT translations, all right, inside local, outside local, all right, and show IP NAT statistics. Total transactions are 2, 1 static, 1 dynamic, 1 extended. Outside interface, serial, inside, gigabit, hits, misses, expired translations 4. All right, and that's it. All right, quick video, but thanks for watching.